Welcome back. Today we started with a quiz. Let's take a look at it. Make my font bigger. That's probably too big. Alright, looks good. Someone asked if we can actually not take the final if you have an A in the class. That's actually already the deal. So, yeah, if you have, I usually make the cutoff towards the end of the semester. It's the low A level. Usually you don't have to take the final, so people around the 93 mark or higher or so should expect that they don't have to take the final. So I guess if you're close to there, then try hard in the final stretch so you don't have to worry about the final exam. And then the makeup for the second exam will have something to do with your final grade. So I'll probably either like replace it with your final grade or scale it to your final grade somehow, something like that. And then, of course, if you can 1v1 me in my game of choice, it's like playing the fiddle against the devil, right? If you beat him in a 1v1, then you get an A. Right, so you have to beat me in a fiddling contest, and then you can also get an A. Which means you have to buy your own fiddle. I will not provide the fiddle. And we have to do it live. So the quiz looks like everybody just finished up. Let's take a look at those scores. Alrighty, right. We got most people responding correctly with 36. So it looks like the majority of people got it here. This wasn't meant to be too misleading. There were a couple small bamboozles for that question about beta's value. So obviously beta doesn't have a value field here, so you might be tempted to say that beta doesn't have one, but it does because it inherits one through Greek. It has the value field that its parent has. And then the superconstructor for alpha and theta just take a value and pass it to the superconstructor, whereas beta does it a little weird. It just passes 5, so it doesn't take a value at all. And Greek has this calculate method. Alpha and beta implement that directly. They don't do anything special. They just use the parent's calculate method, whereas theta overwrites it and has its own calculate that utilizes this other value. So theta's calculate returns the sum of the two values instead of the value times 2 like all the others do. So we've got alpha, which is 10, beta, which is always 5. All betas are 5. And then theta is a 2 and a 4. We want to get their sum. So alpha is going to use the default calculate method, so that's going to give you 20. Beta is going to do the same. That's going to give you 10, because 5 times 2. And then theta is going to use theta's calculate method, which gives you the sum of those two values, which happens to be 6, which gives you 36 altogether. So any questions, let me know. And yeah, you should probably start thinking about the game that you want to play after the final. I'm definitely open to Minecraft, but I don't know what we would actually do. And I guess that's my problem with Minecraft in general. It's not really a problem at all. And if you want to start a club, you know, it's a great thing to do during your time in the university, so you can certainly start a gaming club. You pay a significant amount of your tuition for your clubs and services fee. I don't remember if they line item it for you, but it's a pretty big part of your tuition money, so you may as well use it. If you start a club, you get enough people to sign up with you, the university will support you and you can buy food and stuff eventually. So, something to consider. Fun to do. Why not? Chess fun, we fun. Yeah, e-gaming. Alright. Okay. Let's get back to where we left off last time with the toaster. A lot of classes to open here. Remember, if you just want to open a bunch, you can select them all and hit enter. A little shortcut. Doesn't save you an awful lot of time. I actually like to open them one by one, if you'll notice, when I have a bunch, because I like them to be in the order that I remember. I usually put the driver out in the front. I mean, you can reorder them after the fact, but that's just me. I don't know, I have a particular order that I like. Anyway, let's look at our toaster. We were talking about it before. We have our bread and our Pop-Tart items, and Pop-Tarts and bread both implement Toastable. So, let me take a little bit of a detour here and ask you if there are any interfaces that you can recall from Java so far. Do you have any interfaces that you know in Java at all? Like, we've worked with color, we've worked with a bunch of different things in swing. Are any of the ones that we've worked with so far interfaces? I think not. I think none of the stuff we've used for now are interfaces. They're almost all extensions of some base class and then methods. And I guess you might want to think about why that is, but later on we'll show you that there are some interfaces in the Java library too. But I guess the point of that is to say that you shouldn't be discouraged from using interfaces just because the Java library doesn't. They're still probably the more useful mechanism for inheritance for your work. It just happens to be, for the most part, simpler when you're designing a library to do it the way that the Java library has done it. Why don't you think about that too? Now for the gaming finale, if we did a battle royale, I think only the winner would pass, yes. And then if I won, everybody would fail. That's only fair, I think. Right? And it can't be a team battle royale. I mean, that's just not academic. It has to be individual. But we can do a team tournament to Counter-Strike. Brackets. Best of 50 or something. You bring outside players. No, of course not. You gotta have only people from this class. Minecraft adventure. Whoever builds the largest house within 6 days after the final. Reminder that the final is going to be Thursday, I think, but check the final schedule just to make sure. And I believe it's at a different time than the class usually is. So I think the class starts at 2 and the final's at like a slightly different time. What did I ignore? The streamer thing? We already did the streamer thing. I told you, if I can become featured on the YouTube front page, then of course everybody gets an A for getting me featured. No, I don't care about the YouTube subs, although it was cool to get to 100 just off of basically course enrollment. It was very interesting. Yeah, we'll probably have class here. That's probably the better move. Okay, back to Toastables and everything. But glad you're all having a good time. Alright, so we had our bread and our Pop-Tarts were Toastable. And we basically have nothing on Toastable at the moment, and we basically have nothing on any of these methods. So let's go ahead and think about how we would do this. Or did I forget to post that link earlier? That would probably be useful when you do that. It's very possible that I forgot to do that. Yep. Yeah, I forgot to do that. That's my bad. Okay. If you're just joining us now, you didn't miss anything. I'm just setting up what we did last time, the Toastable stuff. And I did go over the quiz, but you can rewind for that if you missed it. Alright. So, Pop-Tarts and toast are toastable. The toaster has a toast method, it has an insert toastable method, and that was part of the slot interface that we had implemented. So let's try and make this simulation happen. So I'm just going to start with a toaster, and then we'll see if we can utilize slot more effectively later. Actually, I haven't written those methods yet, so I'll go back and do that first. So let's say I have my toaster. I'm going to make a piece of toast. And we'll make a Pop-Tart. Ooh, it's tough. And it looks like I actually had... Oh, it's bread. It's bread, it's not toast until you've toasted it. Okay. And I also need to add an argument to Pop-Tart. It takes a boolean of whether or not it's strawberry. So this is going to be a strawberry Pop-Tart. We'll set that to true. Okay, so first, if you have a system like this where you have, and again, we're simulating anything where one object slots into another. A toaster is a good example because this is a common pattern that pops up. You have your object A has to communicate with object B somehow. And in the real world, when objects interact, and again, we don't want to borrow from the real world too much, but we can. In the real world, when objects interact, they usually interact through some kind of mechanism. You don't just bang things together in order to get them to operate. When you talk to your TV, you've got some remote. When you interact with your computer, you've got a mouse and keyboard. There's usually something that you use to interact with the actual object, and that's why we call it an interface. The method by which you interact with the objects in the real world, we usually call that the interface too. Let's say like the interface to your car, it's like your infotainment system, but it's also like your keys and pedals too. Those are all the interface to those objects. So that's kind of where that terminology comes from. Why they didn't do something like property or whatever, because it's not always adjectives. Sometimes it's something like a slot, which is just the interface by which a toaster interacts with toast. So you got a situation like this where one object slots into another. Toaster implements slot. Let's write our toast method. What does that do? We have a insert toastable. Well, let me make an array of toastables. We'll call it, whoops. We'll call this slots. Say this is a 2-slot toaster by design, as most toasters are. Or we could be more fancy and say public toaster, and we'll take the number of slots as an argument. Could do that as well. Take that approach. Toast. This is a remarkably hard word to spell for me. Okay. Oh, I named it the same thing. That's very confusing. I'm not going to do that. All those num slots. Alright. So if insert toastable is supposed to put something new in the toaster, we've definitely done this before. We have this sort of next slot thing. Next slot equals 0, and then we insert the next thing like that. We have like slots of next slot equals, and then we say t. Oops. And we move our next slot up by 1. If we wanted to make sure that it didn't error out when it was full, we would have to do something like if next slot is greater than or equal to, and then we look at the length, and if that was true, then we would just return without doing anything. That way you can't accidentally overfill your array. So I think we've done that a few times before. Alright, so say you've got to that point. What should I do for toast then? What should I do for toast? How does a toaster work? How does a toaster toast? Print something? Well, that would be a low effort simulation, I guess. Yeah. Well, I guess that goes back to toastable. What does it mean to be toastable? Well, it probably means that you have some ability to be toasted, which means that you should probably get the ability to check if something is toasted. And, well, bread should probably have a method to toast it, so let's give it something like that. We'll call it avoid toast. This will toast an individual piece of bread. Well, notice that has the same name as slots, but these have different meanings. So this one toasts everything inside this object's slots, and the toast that's attached here will toast this piece of food. So those are very different meanings despite the fact that they have the same name. And we'll see that in different places where the Java library uses interfaces. They'll have very similar names for similar things. Let me add these to all of my classes that need them. And change my driver to use a 2-slot toaster, which I conveniently picked so I can toast the bread and the Pop-Tart at the same time. Alright, well I already have a boolean is toast from earlier, so I can return it. Let me set it to private as well. What does toast do? Well, it's a one-way trip. It can't be untoasted. That's why I set it to private, because we never want you to be able to set it to false, because you cannot untoast things. That doesn't make sense. So it's actually going to look exactly like this for Pop-Tart as well. And I'll just, oh, that's already there. So I can just change it to private. Alright, so get toasted returns whether or not it's toast, and toast sets the is toast value to true. Okay, with that in mind, let's go back and finish toasters. What should the toast method here do? Up to spec, it should toast everything inside this object slots, of which it seems you can have more than one. So what should we do there? Toast everything inside the slots. And there could be 2, there could be 1, could be 4. Might be a little bit confusing to have the word slots used a couple of times here with different meanings. We have our slot interface. We also have slots, the array here, so maybe for convenience I'll rename this to something else. Maybe I'll call it Toastables or something. Now I suppose I should rename this to next toastable. So what do we do? How do we toast on the toaster? What should the toaster do? That ought to be less confusing, I hope. That indicates that that array is holding all the toastable things that this toaster can have. But when you think about that abstraction, when you think about that toastable array, if you imagine a two-slot toaster has an array of two toastable things, and before you've put any toast in it, those two slots are empty, they are null. Then after you've put toast in them, or whatever, any toastable thing, then they're full of whatever toastable thing you've got. So they could be empty too. You might not necessarily use both slots. Alright, no one's got it, so I guess I'll maybe give it away a little bit. So let's say you have this as a start. We're going to loop through all of our toastables and then do what to them? Loop through everything that we have in the slots and then do what to them? We can call the toast method, so t.toast. There's one extra step we needed to do here that I kind of insinuated in that real-world example. It's possible for the slots to be null. It's possible to have nothing in there. So we need to do a little null check there, just to make sure that our toast slot isn't empty, that there's actually toast in it. Okay. What else does a slot give you the ability to do besides inserting a toastable? What else do you get the ability to do? What other interactions can you have with the toaster slot, or any other thing that can toast bread? What else? You can insert things into it, and you can take things out. So what do you need in order to take something out of a slot? It's definitely going to be a toastable thing that you pull out of the slot. Right, but do you need anything as an argument? When you pull something out of a toaster, you get a toastable thing back. So we're definitely returning a toastable thing when you pull it out of the slot. But what do you get here? You can have a slot number. Okay, so int slot number, that works. There we go. But this creates an issue for our little toaster example here. The way that we insert the next toastable thing is always at the end. We always insert the next toastable thing at the end. So let's adapt to this new use case where you can actually return a particular piece of toast. So first, you're going to figure out which piece of toast that they want, and that's going to be, I'll just call it T, toastables of slot num. And then if you've removed it, it's not in the slot anymore. So toastables of slot num is going to be null again, because we've emptied it out. Should not have named it that, what a hard word. Okay, and then we can return T at the end. So it's possible for you to remove, say, in a two-slot toaster, the 0th piece of toast. Have the first one still in there. So let's go and alter our insertion method. What can we do to make this work with our new implementation of removal? How can we insert something into the next available spot instead of the next spot on the end. Another common question that you'll have when dealing with lists of things. And one that's really easy to answer in its real-world iteration, right? If you have a 4-slot toaster and 3 of the slots are occupied, very easy for you to figure out which one's unoccupied. But here, still simple, but not as simple. If you've got a 2-slot toaster and 1 slot's occupied, check if one of the spots is null. How could we do that? And we check if one of the spots is null. That's the right answer, though. We want to find an empty spot. We've designated empty spots as null spots. There are other ways to do that, too. You can have placeholder objects that indicate that they're blank. Some folks like to avoid null. In fact, there's whole families of programming languages that try to avoid null entirely. But in Java, blank being null is a not uncommon pattern to see. Okay, so how would we find the first available not null spot in our toaster? Yeah, we want to search through the array. We can do this with the fancy loop, but when we're dealing like this, I prefer to use the traditional one because we're dealing with indexes here, and we probably want to use the index at some point. Alright. And if toastables of I is equal to nil, then our toastables of I will equal t, the new guy that we've tried to insert here. This will automatically do nothing if there are no null spots, right? It will loop through the array, and then if it didn't find any null spots, then your toast just gets left out, which is probably something that you should specify. Attempts to insert this toastable item into an available slot. Does not exist. Does nothing. But there is one more thing that's missing here. There's one more line that's important here. And it's a logic problem that you might find a little bit difficult to understand if you haven't seen it before. Let me show you the problem first. I'm going to make a 4-slot toaster here, and I'm going to write a quick print contents method so that we can see what's in it. So print contents, and we're going to loop through. If it's not null, then we're going to print just t, and that'll print again one of those little Java objects with the weird funky object name and everything, but that's fine for now. That's all I want to see here. So let me see. I'm going to try to add my toast to the bread. Well, I'm going to rename that to bread. Otherwise, that's going to be confusing. Okay. So toaster dot, what did I call it? Insert. I'll insert my bread, and then I'll print out the contents of the toaster. Let's run that and see. So here's the problem. Oh, here's the problem, right? I have the same bread in there 4 times. So what is it about the way that we wrote it? There's a common pitfall I see when trying to add something to the next available spot. What's the problem with the way that we've inserted into the next available spot? What's it missing? Right, all the spots are null at the beginning. Right, so as it loops through and it checks if the spot's null, and okay, it's null, it's going to set it to this piece of toast. But then it moves on and it does that for all the other null spots in the toaster. So it ends up filling all 4 spots with the same piece of bread. So you could break here. That works. That escapes the for loop, right, so that we don't continue to look for null spots. I actually prefer usually to just return if that's an option, if I don't have to do anything else. Obviously break is better if you have more to do. You know, here if you actually have to do something after you do the insertion, then you'll break out of the for loop and do it. But return designates, in this case, I think more clearly that you're done once you've found a place to put the toast. The method's over. So it would happen anyway, because you'd break and then it would just return being outside the for loop, but I chose to do return here. Okay, so now you'll only see the bread in the first spot there. Okay. And let's go back and change it back to a 2-slot toaster. Let Pop-Tart in as well. So we've inserted the bread, we've inserted the Pop-Tart. Can I check from the toaster's perspective if the Pop-Tart is strawberry? Can I check from the toaster's perspective if the Pop-Tart is strawberry? Remember, those are fields of the Pop-Tart here. Can I check from the toaster's point of view if the Pop-Tart is strawberry? Is that possible? What if I had something like the Boolean check is strawberry, and it took slot number inside the toaster, and I wanted to see if a Pop-Tart was strawberry. How would I do that? So if I've got my Toastables array here, copy that. If Toastables of slot num is what? What do I do to fill in the blank there? How can I check if the Pop-Tart is strawberry? Or if the thing in that slot is strawberry, I guess is probably the more accurate description of this method. Returns true if the toastable item in the given slot is strawberry. Alright, so can we just do is strawberry? I don't have it here. Right, I don't have the ability to look at is strawberry, and it is public, so it should be available to me if this were a Pop-Tart, but it's not. And it's not available because our toaster deals only with toastable things, not with actual objects. It deals with their toastable interface. It doesn't care if you're a Pop-Tart or bread or a bagel or whatever. It only cares that you are toastable and that you have the following promises, that you have a getToasted method and a toast method, which is actually the only thing that it ever uses. It actually just uses the toast method. It's the only feature that it uses of Toastable. See, nowhere else do I do anything else. So if I don't care what kind of object I have, then I can't look at any of those object-specific properties like, whether or not it's strawberry, because those are irrelevant to my toaster. So no, I can't do this. Or at least it's not easy to do this. Because, well, this isn't, it's not an appropriate function of the toaster anyway. So if I did want to do that, if I did want to be able to check if it was strawberry, there is a way. I'm going to do that later, though. We'll do it actually not in the toaster, but let's say in the driver, because it's definitely not a function of toasters to determine whether or not a Pop-Tart is strawberry or not. Alright, so let's run the simulation a little bit more. Let's do toaster.toast. So we're going to toast both the things inside there, and then let's try printing before and after. Let's go with is bread toasted? So we'll do the before and after. So should this work at this point? Are we going to get false before and then true after? You'll notice that, like, bread, specifically bread, doesn't get called anywhere. It gets added to the Toastable. It ends up here in the array of toastable things inside the toaster, but we never explicitly call bread or anything. So let's find out. If we run this, we do get false and then true. So this toast method, even though it affects toastables, right, going back, it deals with an array of toastables. It calls the toast method in bread and ends up setting it to true. In fact, we could verify that it does that. We could print out here toasted bread, and when we run this, we would see that it would toast it there. Okay, so let's say you did want to figure out if something inside of the toaster was strawberry or not. So let's say that I did something like this, and I didn't know perhaps what was in which slot. So let's say that I wanted to remove the thing in slot 0, toastable, we'll call it T1. So I wanted to remove the thing that was in slot 0. And then I wanted to check if it was strawberry or not. So I wanted to do like T1 dot is strawberry. So how could I pull this off? Any ideas? How can I check if it's strawberry or not? And then I'll do something if it is. Get the general idea. Well, we could do a cast. We could cast it as a Pop-Tart. Is that going to work? Let's try it. Let's see. Let's cast our T1 as a Pop-Tart. So I'm going to call it a Pop-Tart instead. I'll add the cast there. And then I can do T1 dot is strawberry if I want. So we'll do if T1 dot is strawberry. We'll print something out. It's strawberry. Okay. But as you know, casting is a dangerous operation, because if the thing that you are casting ends up not being strawberry at all, well, then you definitely run into problems. And in this case, what's in slot 0? Well, actually, we put the bread in first. So bread is the thing that's in slot 0. Okay, so that didn't work at all. But it did work, or it would work, if we were removing a Pop-Tart every time and we knew it. So there's nothing wrong with that. casting situation there. But is there a safe way to do this that doesn't involve casting it? Well, there is, but it's a bit hacky. So what we can do is give the ability for toastable objects to return a Pop-Tart. Something like this. Get Pop-Tart. Oops. Public Pop-Tart. Get Pop-Tart. Alright, and what would Pop-Tart return in response to this method? So this would return returns the Pop-Tart attached to this Toastable, if there is one. What would Pop-Tart do for its implementation? So we want to return the Pop-Tart attached to this Toastable. If there is one, what could we do for Pop-Tart's version of that? It's not hard. It's a single line, nothing fancy, but it is a little bit difficult to reason your way through it. So if we're talking about a Pop-Tart, the Pop-Tart is toastable, or it has a toastable, or toastable is a feature of the Pop-Tart, however you want to think about it. These are all valid ways to think about an interface. It has a toastable, it is a toastable. Not so much, but has a toastable, is toastable. Both valid ways to think about a Pop-Tart. So if you have a Pop-Tart that is toastable and the toastable feature of it gives you the ability to get the underlying Pop-Tart, what would you do in this method? Just look at the context, look at what class we're in, and then think about what you need to do in order to successfully return a Pop-Tart in this case, or actually the Pop-Tart that's being toasted. And this is, to an extent, a pretty silly thing to do, but it actually is the, I suppose, safest and easiest way to invert the little hierarchy that you build with your implementation. So if you want to get an object higher up, in this case, Pop-Tart implements Toastable. If you've got a Toastable and you want to get the higher up version, the parent, the Pop-Tart, this is the only way, basically, safely to do so. Return a new Pop-Tart wouldn't be the right answer because we want to return the Pop-Tart that is implementing this Toastable. We want to return this Pop-Tart, this particular one, because if you have Pop-Tart and it's toastable and then you ask the toastable functionality to give you back the underlying Pop-Tart, you would expect the same one. You wouldn't expect a new one. So we can actually just return this, which returns this Pop-Tart. Again, very confusing, but this allows us to start with a child class. So Toastable is something that Pop-Tarts implement and allows us to get back to Pop-Tart from there. Now, obviously, the problem is that Bread's version doesn't make sense. Bread doesn't have a Pop-Tart to give you, so Bread would just return null or some kind of placeholder value, and then when you're determining whether or not something is a Pop-Tart, you could say toaster.remove 0.get Pop-Tart, and then we would check if it was null before we attempted to do anything. So we had to add a little bit of an extra step there, but we avoided having to perform a cast. And now if you try to remove the Pop-Tart at slot 0, which is actually not a Pop-Tart at all, you'll get null. It won't pass the null check and everything will be fine. If you try to remove the Pop-Tart at slot 1, which actually is a Pop-Tart, then you will get is strawberry. So again, avoid this pattern unless you have to, but this is a pattern that you will occasionally end up running into. It is preferable usually to the casting pattern, just because the casting pattern again results in somewhat dangerous behavior, results in you occasionally getting the wrong thing back. So with that, I'm going to introduce a little bit of a new concept today, and that's what to do when you expect an exception. So I've shown you how to do it without ever generating a exception, so without ever accidentally getting the wrong thing back when you cast. But there's actually a way that we can handle our exceptions properly and deal with bad casts without causing the program to crash. So this is one way to do it. Let's go back and do it the previous way. So let's say I want to loop through all of the things inside the toaster. So for I equals 0, I is less than, what do we got? Toaster dot toastable stop length I plus plus. And just to avoid confusion, I'm going to get rid of this next toastable thing that we don't use anymore. Okay, so if I was to loop through all of them and I was to pull things out of all of these slots and I wanted to treat them as a Pop-Tart, so Pop-Tart B equals toaster.remove, and then every generation that I'm in the loop, and then I did the casting. In order to be able to do so, as we noted earlier, this gives you an exception when you run into the bread. So if you run this, you get an exception when you run into the bread. Bread cannot be cast to interface, blah, blah, blah. So what you can do when you want to deal with situations like this where you expect an error is to implement your exception handling. And exception handling is formatted like this. So you have what you're trying to do, which is try, haha. Okay. And then you have your catch, and then you can generally print what happens in the event of the catch. Let's look at what this does. Okay, I've got bread cannot be cast, and then null pointer exception here. So I had two issues come up. So the null pointer exception comes from, obviously, I had already removed the Pop-Tart in slot 1. The class cast exception comes from my attempting to cast bread as a Pop-Tart, which is obviously incorrect. But look at what happens now if I continue on. So let's say that I want to print out something here. Here we are. We'll see that it actually continues to execute, which is generally not the case when we run into an exception. Generally, we just stop. So what exception handling lets you do is deal with a exception, handle it properly, and then move on. If I erase this e.print stack trace line, you won't even see any red. E.print stack trace lets you see the exception that occurred and all the little information about it. If you get rid of that, then you don't even see any of that red. So in this case, handling the exception is really straightforward. We have Pop-Tart expected. We got a piece of bread. What we're actually supposed to do is nothing in this context. We just ignore it. And essentially that's what this is doing. If we get null, or we get, well, if we get null here when we're trying to figure out if it's strawberry, ignore it. Catch it and ignore it. If we get a piece of bread when we were expecting a Pop-Tart, catch it and ignore it, and continue on. So let's do a simpler example. To get into it, I'm going to make a new package. Call this exceptions. Yeah, that's good. And I'll close out of these. Exceptions are really useful for dealing with interfaces for exactly this reason. Let me also sync this up to the GitHub. Finished our posting example. Perhaps we'll do more with it another day, but let's do a little bit of exceptions for now. Alright, so I'm going to make a driver, and I'll probably do everything in there. Driver main. So first, think of a couple of operations that would definitely fail. I'll give you one example that's pretty obvious, but you can try to think of some others. So let's say we have x equals 5, y equals 0, and we want to do int a equals x divided by y. Obviously, this is not going to be successful, right? We run this, we're going to get a divide by 0 issue. So what if instead of just going forward with it, we did this? We did a try, and then we did a catch, and then we did our exception. And I'm going to declare a outside here. A equals 2. What do you think would happen in this instance instead? So any guesses as to what would happen here instead? What's going to be the value of a at the end of this process? So there would still be an exception, but what this allows us to do is to handle it and then continue running accordingly. In the interface example that I started with, we just had to ignore the exception. Here, let's say that we actually want to do something about it. And what we're doing about it in this instance is that if we get an exception, we are setting a to 2. So what we're going to end up with here, actually, when we run it, is 2. And basically, exception handling gives us the ability to say, if there's an exception, then do the stuff inside of the catch block, and then we're going to attempt to move on with the rest of the program. So if we get an exception, which we do here, we get a divide by 0 exception, then it will execute everything inside of the catch. Exit everything inside the catch. Ever anybody think of another situation where you tend to get exceptions, or where you might get an exception? move this to its own method so it's not too crowded. It's just moving things around. So an out-of-bounds exception, let's see what happens when we try to fix an out-of-bounds exception. So let's say I have an array of integers and it's 5 items long. So I've got some numbers here, a new int, and it's 5 items long. And let's say I wrote my for loop like this: I equals 0, I is less than 10, which is obviously bigger than 5, I plus plus. And I want to simply, let's say, print the number. So I'll go with numbers of I and print it out. So obviously if I run this, I'm going to get my out-of-bounds exception after I get to the 6th number. So all the zeros are fine, but then of course once I get to the 6th number, I get an out-of-bounds exception. So I can surround this attempt to print inside of a try and catch. What do I want to do in the alternative case in this situation? So I could do nothing, which is what I've got here. I could just ignore it. Ignore the exceptions and move on. What else could I do? What should I do actually in this case? I should actually break, right? So if I've gone out of bounds, I shouldn't keep going in the for loop. So I'll call this out of bounds. If I've gone out of bounds, I shouldn't keep going inside of the for loop. I should break out of it and then not continue. So actually, let me do something slightly different. I'm going to print I each time, and I'll print it inside these little brackets so that we know that it's the index. Little brackets there, and I'll actually just do a regular print, so it'll be on the same line as the number. So I've got 0, 1, 2, 3, and 4 printing successfully, and then 5 gives you an exception. Let's say that I wanted something to print here as well. Let's say I wanted to print exception or something, for example. How could I pull that off? So before it finishes, I wanted to print like exception on the 5th slot. How could I do that? So before the break line, if I print exception out, then it will print all of the numbers, and then it will print exception once it actually runs into the exception. So again, you can kind of think of these as an if statement. If there's no exception, it's going to do the normal thing, the basic thing that's inside of the try. And if it runs into an exception, so if there's a problem, then it will execute the catch block instead. Now, if you have further problems inside of the catch block, so for example, you insisted on continuing to divide by 0 in the catch block, it would still fail. You would have an unhandled exception, it wouldn't move on. But by handling it and doing something that is safe inside of there, we can get our 2 and continue with the rest of the program. So I'm going to copy all of this into a method again to keep the main area relatively clear of stuff. Any other exceptions that we run into occasionally? What's the other really common one that we tend to get? What's the other really common one that we've tended to get a lot? The one that we've been trying to avoid with objects. Yes, that null pointer one. We run into that one a lot, don't we? We always have methods like this. Let's say we have, should I make a new object? No, I'll just use a built-in object. Let's just use string, for example. So public string, get null string, for example. Okay, and this will take string s as an argument as well. So we have our procedure to, let's say, I don't know, we want to cut it in half or something. So we want to do string dot substring starting at 3. Alright, and then we want to return that. Let's say that's the normal case. And then we call it by doing, just making everything static so I can invoke it in main without having to make an instance of driver. Doesn't matter here. So I want my get null string example, and let's say that I try to do it on a null string, which is not going to be too uncommon. In that case, I'm going to get my null pointer exception because I can't do s.substring on a null string. In this case, we can do a try and catch, but we can't just ignore it, can we? Why not? Why can't we just ignore it in this case? Why couldn't I just leave this blank and allow us to ignore it successfully? We are obligated to return a string object because the method returns a string. So we could return something else here. We could return null. Null is a perfectly fine thing to return, so it would continue. But we were obligated to return something because this method says that it returns a string. So even though the catch block doesn't execute most of the time, when the catch block executes, we are still obligated to return something. So if our try didn't work, that means our return wouldn't work. That means we have to return something in the catch instead. If we also structured it like this, it would also be fine, because that would still guarantee that we are returning something with every execution. And so you could use this try-catch functionality to replace different situations, like let's say earlier we looked at, I think it was in Toaster, we had to do this. We had to check if the Toastable of I was equal to null. We could actually do a try-catch there, but that's probably not the best place. The best place is somewhere like this, where we're trying to print out the contents of the toaster, and we wanted to print out all of the non-null contents. Or somewhere like this, for example, we wanted to toast all of the non-null toastable things. So we could just replace this with its equivalent, try t.toast, and then catch our exception. This would work exactly the same way. If we get a null object, it would go to the exception, and it would simply ignore it in this case. So I'll leave this commented out and write you a note. Works the same as the above in this case. So it gives you an alternative for dealing with those null pointers. Alright, that's it for today. Next time we'll do a little bit more exception handling, show you some fancy stuff with it. You definitely don't need to use it on the homework. There will be a new homework up about interfaces tonight, and you've obviously got a homework due today as well. Yeah. see you next time.